In this reaction, we have some information about cyanide gas. It's being manufactured from methane and ammonia with a catalyst at 1200 degrees Celsius. None of that information is useful in that first sentence. Now here's a useful reaction. Okay, we've got the balanced chemical equation. Okay, 1 nitrogen on each side, 1 carbon on each side, and a total of 7 hydrogens on each side. And the Kp is 470. And we have the delta H. So that's all useful information that I've underlined, okay? So, which manufacturing techniques would enable the production of more HCN, that's this boxed chemical here, under equilibrium conditions? So this means we want to shift this reaction to the right. Let me make a jot of that so you can follow the logic. So if we increase the pressure of the reaction chamber, what would happen? Let's count the coefficients. Change color here. We have a coefficient of 1 and 1. So the total number of moles of gas on the left side of this equation is 2. We have a 1 and we have a 3. So that's a total of N equals 4. Okay? So if we increase the pressure of the reaction chamber, the whole reaction, this reaction is going to shift or respond to that stress by shifting to the left. That does not make more cyanide gas. If we increase the partial pressure of ammonia, that's the same as increasing the concentration of ammonia. If we increase the concentration of ammonia, we're going to shift away from the increase or shift right. So B is correct choice. If we increase the partial pressure of H2, that's the same as increasing the concentration of hydrogen. Here's hydrogen on the right side of this equation. If we increase the pressure and or the amount of hydrogen, it's going to shift left. It's going to shift away from that increase, so that's not going to increase the production of cyanide. And what happens if we increase the reaction temperature? So here we need to think about the delta H. Delta H is positive 60 kcals per mole. That's endothermic. In an endothermic reaction, heat is absorbed. So let's go ahead and add heat as a reactant to this chemical equation. And let's incorrectly think about adding heat just to the left side of this equation. If we increase temperature, that's the same as adding heat. And think about heat as a physical substance here that can only be added to one side of a chemical reaction. It's not correct in a physical sense, but it helps us think through the process. So if we add heat to the left side, we shift away from the increase. So it's going to shift right. Again, if we shift right, we make more HCN. So that would indeed increase